Okay, we're doing a second day on identities. Is this always true? No, because couldn't you put in a number for x and find out it didn't work? All right, because you start with something like this and think, well, of course, because you said it was true. No, this is not a truth statement, okay? Is this always true? And how can you prove that it's always true? You can take any value of x and put it in there, and it'll be true, right? Okay, so these things that we learned yesterday, those are more like this. They're more like a truth statement. They're an identity, all right? So let's go to this one. Is this always true? Nope. Some angles would work, some would not. All right. Let's go to this one. Is this always true? Yep. No matter what the angle is, if you do sine of that angle, it will equal sine of that angle. So it's interesting because you kind of went back when I started with this one, you kind of think that, well, that must be true because you said so. And there's a different standard for truth. And identities are true. And they are different than just saying x equals 1. These were the Pythagorean identities. Cosine squared plus sine squared equals 1. Now, if I were you at this point, I would pull up that file too and have it handy, because in the middle of a problem, you are allowed to refer to a formula sheet. But I'd like you to have these memorized. The ones I gave you yesterday were all the ones you'd have to memorize. And then we're going to explore some really complicated ones, which I would not need you to memorize. Just like my philosophy on life and memorization, you should memorize some things. But you can look up the complicated things. So math-wise, I would expect you to know 9 times 6. I wouldn't expect you to know 98 times 65. It'd be natural for me to expect you to probably go to a calculator for that one. Well, these are easy ones. In fact, if I was going to pick only one, though, I'd pick that one. You know why? Because you can get the other ones from it. Remember how I got the other ones? I took this and I divided by... what? I divided everything by sine squared. And that got me one of the facts. And then one of these two came by dividing everything by sine squared, and one came by dividing everything by what? Cosine squared. So therefore, if you're going to pick one master one, it'd be this one. Because you can just take it and create the others. All right, so these are really good hints for verifying identities. A lot of times we just call these proofs. You got to prove that this equals that. Take the more complicated side and work on that side. Okay, so if there's a left side and a right side of every proof, take the more complicated side. Next, you're going to use the reciprocals and the quotients a lot. I gave you a list of all of those yesterday. For example, what is the reciprocal of sine? Sine is equal to what? 1 over cosecant. All right. And how about the quotients? What is the quotient one that's related to tangent? Tangent is what? Sine over cosine. Because you didn't say that very fast, it makes me suspicious that you don't know those ones that I gave you yesterday. You do need to know those. All right, next up, it says obtain common denominators. I want to give you a minute on common denominators to show you why you'd care. Let's say you had 1 over cosine, and we didn't want to change that into, what could we change that to? Secant. But we didn't want to change it to secant. Why? Because something over on the other side, let's say we were trying to do this. 1 plus 1 over cosine is equal to, well, the thing on the other side has a cosine in the denominator. So I don't want it to disappear. Okay? So I'm going to ask you to prove that this is equal to cosine of theta plus 1 over cosine. Prove that that's equal to that. It's going to require you to be able to do a common denominator. I'll pause for a second while you and your partner take the red side and try to get it to have a common denominator. Okay, so here's how you do it. First, we give it the denominator. Then we're going to multiply the top and the bottom by cosine. And then just cancel them back off again? That'd be dumb. Why'd we do that? So that we'd have a common denominator. Now I should add them together. When you add two fractions that have a common denominator, like 1/7 plus 3/7, you don't add the sevens, do you? You leave the denominator alone, and you add the tops. And so the answer is 1 plus, well, actually, it's cosine theta plus 1 over cosine. Would I have allowed you to just reverse them when you write it? Yes, because if you left it like this, are these truly identical on both sides? No, they aren't. They are not identical. Yeah, I know it's. Oh, wait a minute. Actually, dang it. I said all of that because I thought it said 1 plus cosine. 1 plus cosine is not identical to cosine plus 1. But I actually did have them in order here. I didn't intend for that. I intended to map them backwards. So anyway, yay. It's identical on both sides. And did I follow all the rules? What are the rules? Tell me one of the things you have to do. You can't just write two things that are equal and then, yay, you win. Yes? Can only change one side. Did I ever mess with the right side? Nope. I left it alone. And the one last rule, you can only make substitutions that are legitimate. Could I substitute in cosine over cosine here? Yes. You can do that because you can multiply by 1. That's a mathematical... that's just following the rules of math. All right. Would you please find this one? Number 1 is laughably easy. In fact, don't even do it. It's insulting. Go to number 2. It's a little more challenging. I know some of you might have to flip to find this thing, but I've been assured that it is in the notes. This is the notes that are on the same homework as yesterday. So like yesterday's notes. Anybody want to help out with what page it was on? Apparently it's on page 6. Okay. I hope you saw that you could do a little substitution there. Let's see what a random person did. Row 5. Last person. That's you guys in the back. What did you guys do? Could you guys... I can't hear. What? All right, so you swapped out secant. You put in 1 over cosine. So now we have sine theta, 1 over cosine theta. Why can you do that? I'm not saying you're wrong, just asking. One of the identities. Yes. We all agreed on certain facts. That's one of them. Okay, awesome. Now what? Sine theta over cosine theta. Yes. And then? And it'd be very tempting to just leave that on your paper, but you'd get it marked wrong because you haven't done a proof. Yep, so we just need to bring this all the way down. And I'm okay with you skipping a few in there, and just you do have to have it at the end, though. There we go. Tangent of theta equals tangent of theta. Did we only mess with one side? Yep. All right. These were your homework from, are they? I think they're homework from yesterday, aren't they? No. Okay. See if you can find this one. Is this page 7 in yesterday's notes? Okay. Then try number 82. That's pretty easy. As soon as you guys are done with that one, try 88. Not super hard yet. These are all pretty easy ones. I'll pause for a second while you try those two. There's no easy way to do this besides actually practicing doing real problems. So, okay, let's see if you were able to handle these. Row 5, person 3. 1, 2, 3. That's you, AW. Tell me what to substitute on the left problem here, number 82. Took out cosine, put in 1 over secant. I like it. And then this is just a secant. So then I'm going to put it over 1 just to show my work really well. It's the whole point, you guys. Do you get... I know that this is true. You know? Like, you have to not skip any steps. That's the whole point. So then this becomes 1 over 1 times 1 over 1. And then that's 1 equals 1. Yay. Okay. Moving on to the right-hand side. Row 6, boy, we're beating on the last 2 rows here. Person 3, that's you. Tell me what's a substitute on problem 88. Okay, I got lost in there. I get that you changed the left side. What did you pull out? Oh, you were doing the right side. Okay, so you took out cosecant and you put in what? 1 over sine. All right, that's definitely legal. It's right off the sheet. And then how about cotangent? Did you immediately switch cotangent or did you save it for a later step? All right, you can do that. You immediately switch cotangent to what? And one of the things we haven't talked about that much is when you have a sine times a sine, I hope you guys get it, sine squared. So I have cosine of theta over sine squared of theta. Okay, then isn't that what I wanted? Can I just leave it like that? Nope, I have to bring down this side and have a truth statement. We're picky because this is a proof. We already know that the answer is true. All right, moving on. These we did as homework. These we did as homework, but we didn't do 102. Now, I'm officially assigning it. I'm adding it to that old homework. So if we collect this homework, you'll have to have this one done too. Okay? So get number 102 done with your partner. It is definitely more complicated. It's not impossible. One thing I want to bring up, you've never seen the tangent cubed before. Take a wild guess what they're going to split it into. A tangent and a tangent squared. Okay. All right, I'm going to pause for a minute while you try that. Okay, without giving you like a bunch of steps, let me just talk strategy with you for a second. Somebody who's done a lot of these. What I encourage you to look at is which side do I want to mess with? I could do it from either side. Either way could work. So if you try it from this side and it doesn't work, then try it from the other side. But I will tell you that the answer I'm going to do takes the left hand, manipulates that side, and then gets the right side. Okay, so how about this left side? I already gave you the hint that tangent squared and tangent would make a total of tangent cubed. So obviously you can split those up. But wait, look at what you don't have. What don't I have here that I want to have at the end? I want to have a subtract and a sign. One kid said sign, one kid said subtract, and yeah, I'd like to have both. Do you get how I need a sign and I need a subtract sign? So then think to yourself, which of the formulas that we have agreed upon, which are the identities, has a minus and has a sign squared in it? All right, so it's actually this one. And you might be like, but that doesn't have a minus in it. You're right, but it could. Do you get if I subtract cosine squared from both sides? Now it's going to have a minus sign in it. So then that cancels, and sine squared is 1 minus cosine squared. But I don't want cosine, Mr. Server. I want sine. Okay, fine. Then we'll subtract sine squared from both sides. If I subtract sine squared from both sides, that cosine squared would have a 1 minus sine squared in it, wouldn't it? Do you get how that gets us closer? If we do a swap where we replace cosine squared with 1 minus sine squared, that would get us closer. I'm not saying you need to do that right now. You could do other things first, but eventually you look at what you want that you don't have, and you figure out how you can make that work. All right, I'm going to pause again, give you a little more time, see if we can do it. Okay, so I give for the people that are listening at home, I gave the kids a fair amount of time, and I know a lot of people are stuck at this point, and I want you to, well, first of all, how many of you got it? You were able to pull it off. Okay, one group. So, do you get how hard these are? We have a lot of really smart kids in the room, and without being able to look at the key, it's hard. Okay, so I'm going to walk you through, and I think you'll see each step is like, yeah, you can do that, but I wouldn't have thought maybe to do that. All right, so pay close attention, and I would follow every step. Okay, all right. So first, I'm going to pause for a second. Okay, so I got it fixed here. Here we go. So first step. Oh, I hate when that happens. You know what? I'm going to just delete this so that I don't have to have it go back and forth over and over again. That's how many steps it takes. That is a typical hard R3 on your test. So you got to get better at this, obviously, right? All right, I know it's going to be hard to read, but I'll help you. First thing is, do you remember me saying that tangent would be broken up into the two tangents? And they separated them from each other, just to make it really obvious that their tangent is separated from their tangent squared. Okay? All right, so that's just the tangent to the third got broken up. All right, next, would you agree that it's okay to replace tangent with sine over cosine? Did any of you guys think of that? Okay, a bunch of heads are nodding. All right, good. Then, would you agree that these cosines would cancel right there? Does that make sense? So what are you left with? There is a flawed regular, this is not squared there, I apologize, regular tangent. You're left with a tangent times sine squared. The sine squared, do you remember me saying that I thought we were going to have to bring in a 1 minus one of those? Would you agree that sine squared is 1 minus cosine squared? Is that a legal swap? Now remember, there's a parentheses right here. I'm going to undo that circle. There's a parenthesis right here, and they multiplied it out. Why did they do that? Well, at the end, there was no parentheses in your goal. So your goal is this. You keep coming back to your goal and say, well, does it look like that yet? At least we have a negative. We have a tangent, and we have a cosine, so we still need a sine back in here. And it seemed kind of strange to pull out the only sine we had and put in a 1 minus cosine, but it's going to work. All right, so after this gets distributed out, do you see we have this? That's just distributing. Just multiplied it out. Then, again, you look over at your answer and go, well, I still need a sine somewhere. Oh, I can pull out tangent and put in sine over cosine. See how tangent turns into sine over cosine? And that's also good because then the cosines can cancel because we've got a cosine squared here and a regular cosine here. And when the cosine squared gets canceled with a regular cosine, there's still one cosine left. And before you know it, it's exactly the same as the right side. And it's done. Left side equals right side. As I did each step, didn't it seem kind of easy, right? But it's like seeing what could I do? You got to go through lots of options. I decided to try a different route while you guys were working on it and see if I could do it a different way. Totally failed. So it happens a lot. You definitely want to take this test when you do take it in pencil because you'll go down this road and you'll be like swapping this out and you think it's going to work and then you're like, wait a minute, this isn't going right at all. And you have to erase everything, try some other way. You know what I mean? So this is definitely a, if you don't succeed, try again kind of thing. And it's, a lot of you guys really don't like the frustration of, you like wanting to know exactly how to do it, and then I'll do it. This is one of those units where you have to like go, okay, I'm going to try lots of things. You got to think of it that way. I'll try it this way. Oh, that didn't work. I'll try it that way. You don't just have an automatic system that'll always work. And you learn the system and you work the system. You have to be able to adapt. Try different things. All right. So this, I don't want to do that one or that one. Well, those are just old ones that we already did. Answers all shown out. So then let's get into the new stuff. This is the part where you'd want to get the new notes up. And I need to teach you about something called conjugates. And that's a new technique. Along with getting a common denominator, I also need you to know how to do conjugates to be able to assign you your homework for tonight. I'm going to just tell you, since we're on that page, what the homework is. But believe me, you don't want to try to like just go do your homework and not listen to this next part. Conjugates will be the key to one of your hardest problems. Okay, there's certain things you have to like know to be able to do well on your next test. One of them is common denominators. One of them is conjugates. So we practice common denominators. Now we need to practice conjugates. But your assignment's going to be just like last time, 3 proofs. The problem 86 here, problem 104, and problem, I guess you'd call it 1. So this one, see on the page that has gray?
Yeah, it's above the other one.
Okay, so it's the reversed order in yours? Yeah. Thank you. All right, but this you may skip. Now, what's important about this is that you practice, that you try. You need to get used to struggling. This is not, like it's not comfortable. It's not going to be very fun. You got to struggle with these. You're going to be tempted after 30 seconds to go, I'm just going to look at the key. Okay, but you aren't going to be able to do that on the test. You have to get used to try, and like if you were if you're going to become a Navy SEAL, they can't have guys who are just like, I just don't understand. I give up. They like, well, you work the problem. You figure out how to do this. You have to try something different. You have to adapt because you're on your own. Okay, so you can't just afford to say, I'm just going to go look at the key. If you do that for this whole unit, you will fail this test. You got to get used to struggling through, and you don't try forever. You try something for a good solid 5 minutes, though, before you go look at the key. And then, if I were you, I'd just give yourself the first step. Just try to get it. Oh, that's how they start it. Well, maybe I can do it from there. Okay? All right, so those are the 3 that I'd like you to try. Now, here's conjugates. First, you have to understand why you care. All right, so this one, sine squared plus cosine squared equals 1 is super fundamental. And if I subtract cosine or sine, either one, from both sides, I get a new identity that's also true. Sine squared theta equals 1 minus cosine squared theta. This one comes up a lot. I'd say it's second place to those quotients, tangent and sine over cosine, and the reciprocals, which is sine gets replaced with 1 over cosecant. Those happen the most, but this happens the second most. You got to be able to recognize, 1 minus cosine, that's what sine is. And I don't even need you to memorize it, but I need you to recognize if there's a 1 and a minus, it's probably this one, except it's been rearranged. Okay, so do you get that that also means that this is 1 minus cosine of theta times 1 plus cosine of theta? Because if you can factor it, you should. Okay. So whenever you see This, you can also know you could break it up into these two pieces. Okay, so if it was this, that'd be too easy. Do you get what that would simplify down to? What would you pull out and what would you put in? Yes? Yeah, I think you meant 1 minus cosine squared theta would be changed into sine squared theta. You are correct, and then it would simplify down to 1. Okay? That would have been too easy. But what if they do this? Just 1 minus cosine and is not squared. Well, then it doesn't work the way it is. So, anybody got any ideas what you could do? I've told you the word conjugate, but I haven't told you how to do it, but I bet somebody's going to figure this out. 2 people are raising their hand. Good for you for knowing. Let's see if we can stretch some of you other guys that aren't participating as much. Think about what I just said before this. What was I just talking about before this? Talking about factoring things. What do you think? Yes, you absolutely could take sine squared and split it up into, what was it again? 1 minus? Hold on, just you're going way too, that's awesome, and you're right, but I'm just going to first replace it with this. Would you agree with that? Okay, and then wouldn't 1 minus cosine squared be able to be split into, what did you just say? Yeah, because this could be factored then into 1 minus cosine. That squared, sorry. 1 minus cosine and 1 plus cosine. Now, one word that you don't know yet is conjugate. This and this, those guys, are conjugates. It can be as simple as this. 1 plus x, what's the conjugate of that? 1 minus x. Sine plus 2, what's the conjugate of that? Sine minus 2. See, some magic happens when you multiply something by its conjugate. You don't have to write this down, just watch for a second. If I use the conjugate and I multiply it out, I'll get sine squared, which is good because then it brings it into that part of the sheet. Anytime it's got sine squared, you're in the Pythagoreans. And then the outside and the inside would cancel each other, right? And then the 2 and the 2 would make a 4. It brings a sine squared and a minus in, and then a lot of times that's what you want. Okay, so what's a conjugate? What is the conjugate of 1 minus cosine? 1 plus cosine. All right, so we're going to start this problem over again. Remember me saying there's a lot of different ways to do these, a lot of different things you try, and then it works, and then, or no, if it works, you're done. But what if you try something that doesn't work? All right, so back to this problem. Now that I told you what a conjugate was, what's the conjugate of 1 minus cosine theta? 1 plus cosine theta. Try multiplying that on the top and the bottom. What says I can do that? What isn't that? You can't just go multiplying by things, but I'm multiplying by 1. Okay. Now, simplify it down from here. Pause for a second. Let me give this one a shot. Okay. Did you realize that the whole point of this is that the bottom turned into 1 minus cosine squared? The top, I bet you most of you guys got suckered into multiplying it out and distributing it. But I'm going to make you think about that tendency. Do you get that right now the top is factored? And if you can factor it, you should. So if you multiply it out, you're like unfactoring it. Don't do that. Why would you not want to multiply the top out? Because now we can replace the bottom with what? That would just factor it back out again. Sine squared theta. Because that's what 1 minus cosine squared is. Where are you getting these from? I'm getting these from sine squared plus cosine squared equals 1. All right, so that's gone. And then wait a minute. That means this can cancel. And it simplifies down to 1 plus cosine. Now, we did this in 2 different ways. Somebody at the beginning had a really good idea of how we should do it, and it worked. But this conjugates thing, it's going to be powerful. You're going to use it a lot. Okay, so I hope I've stressed this enough that if you see this just sitting by itself, you should be thinking of, okay, it could be 1 over secant, but it's very likely going to be 1 minus sine. Okay. And then I hope that you then go, since this is equal to this, then I could, if I needed to, break that up into what? 1 plus sine and 1 minus sine. All right. You'll get smarter by the time we need to test on this. But you won't if you take 3 days off. Make sure you do your homework. Those 3 proofs plus maybe some others. Maybe ones you skipped before. All right. Have a great day.